Okay, uh, I'm going to try to highlight this process one more time and get all the way through some of the algebra. Remember, my effort here is to show you that these horrible looking cubics with square roots nested inside, that we can show that some of them are equal to an integer solution, like the sort of problem that I started class today with. So as a start, just to back all the way up, I suggested we look at this cubic, and I noted that Cardano's formula gave solution x equals cube root of 10 plus 6 root 3. Oops. I believe minus cube root of negative 10 plus 6 root 3. We will show that this is equal to 2. And to convince yourself real quick that 2 is a solution, I did this again. This should be x cubed. To convince yourself that x equals 2 is a solution, just let's plug it in. 2 cubed plus 6 times 2 minus 20 is 8 plus 12 minus 20, that equals 0. Yes, so 2 is a solution. So we hope to prove that this up here is equal to 2. By the way, these are called, people refer to these as nested radicals, or nested roots, nested radicals. So we're looking at a method to simplify a nested radical. Okay, first step. We're going to focus on this term right here. In essence, we're going to try to simplify this nested radical. We can set to be the cube of some number of that form. So in other words, we're saying the cube root of 10 plus 6 root 3 is a plus b root 3. Okay. First step, we need to multiply a plus b root 3 cubed. And what we get believe it or not, I don't have that piece of paper right in front of me. We get a cubed plus 3 root 3 a squared b plus 9ab squared plus 3 root 3 b cubed. Rearrange. In essence, I'm pulling the two terms with the radical off to the side here. Times root 3 then what I notice is that going back to this statement here, a plus b cubed, which I just multiplied out, is equal to 10 plus 6 root 3, and in particular 10 plus 6 root 3. So I'm going to suggest that this term must be equal to 10, and this term must be equal to 6. So my next step is solve that system. So now I have a cubed plus 9ab squared equaling 10, and 3a squared b plus 3b cubed equaling 6. If I in essence multiply these by each other, I get 6 times a cubed plus 9ab squared must equal 10 times 3a squared b plus 3b cubed. Simplifying all of this brings me to a cubed minus 5a squared b plus 9ab squared minus 5b cubed equals 0. Divide by b cubed, and I get a over b cubed minus 5a over b squared plus 9a over b minus 5 equals 0. And by letting y equals a over b, you see I have a common cubic. Well, maybe that's not so helpful. Remember that the original whole problem was to solve a cubic equation. And now as I'm trying to reduce all this, I'm stuck back in the middle of a cubic. And it almost would like, okay, to solve this, I have to go back to Cardano and get another mess. Instead, I'm going to just use the rational root theorem here to simplify our life. And the rational root theorem says where r, let me use another color. Call this coefficient r, and call this coefficient, which as you can see is 1, call that s. And the rational root theorem helps us to see if there might be a rational root to a polynomial. And it basically says there is a root, there might be a root of the form r over s. So in this case, our r was the potential factors of 5. And maybe I said this is the r term. Actually, it's not. The question is, what are the factors of 5 and what are the factors of 1? So where r, I'm going to change color. Our r term was plus or minus 1 and plus or minus 5, and s, the factors of r were plus or minus 1, plus or minus 5, and the factors of s are plus or minus 1. So r over s has the potential to be plus or minus 1 and plus or minus 5. If r equals 1, oh, press the wrong button. Sorry about this. So I'm going to do this back at this screen. If r equals 1, I have 1 cubed minus 5. So 1 minus 5, that's negative 4, Plus 9 is positive 5. Minus 5, that is 0. So in fact, my first guess seemed to work. I'll just write, it is a solution. So that means y equals 1 is a solution, which we said y was a over b, which implies a equals b. Okay, if a equals b, I'm going to go back to two equations I had written before. One said 6a cubed plus 9ab squared equals 10. And the other said 3a squared b plus 3b cubed equals 6. And if a equals b, I have 6a cubed plus 9a. That's not a 6. I'm sorry. I'm just misreading my notes. This originally said a cubed plus 9ab squared equals 10. And simplifying, I have a cubed plus 9a cubed because a and b are equal to each other equals 10. So this suggests 10a cubed equals 10. A must be 1. And then I'm going to check for b over here. So I have 3b cubed plus 3b cubed equals 6. Again, 6b cubed equals 6, and it suggests b equals 1. So going back to that original sort of assumption, where we had said the cube root of 10 plus 6 cubed should have the form a plus b root 3. That means so there I have solved for my a and b. So I know that the cube root of 10 plus 6 root 3 equals 1 plus 1 root 3. So my solution to this cubic, which was written cube root of 10 plus 6 root 3 minus the cube root of negative 10 plus 6 root 3. That's the same as saying nope. So now I'm substituting this in for the cube root of 10 plus 6 root 3. So I have 1 plus root 3 minus, and so granted we didn't do exactly this term, but the mathematics works out very similarly, and we get negative 1 plus root 3. And you'll see this simplifies to 2. Done. I'll just leave it at that. I hope that that bunch of algebraic work helped demonstrate that these nested radicals may possibly be a true integer solution. And in fact, Cardano's formula is giving us correct solutions to the cubic. They just don't appear in a friendly way for us. I'm not going to ask you to simplify any of those results of the Cardano's equation, but you can rest assured that the result you get may possibly be what the graph might suggest looks like is the root, or other methods lead you to the root. I remind you that you can always type in a statement like this one into Wolfram Alpha, and Wolfram Alpha is a pretty powerful calculator. It should let you know that that is exactly equal to 2. All right, I hope that was a little helpful. We'll see you on Thursday.